In our last lesson, we talked about projectile motion, which is a real-life application problem we can use our skills for solving quadratics to apply to in order to solve those problems. We talked about finding maximum height. We talked about when a projectile would hit the ground. Again, solving those quadratic equations that apply to projectile motion. Another application that we can use quadratic equations for is area. So if we look at our notes for today, the first problem gives us a rectangle, and it says, given the diagram, find the value of x when the area of the rectangle is 21 square meters. So the area is 21 square meters. And for a rectangle, we do need to remember, and I think most of you do, that the area is length times width. So we're always going to be taking the length, which is the long side, times the width, which is the short side. So here they're labeled. The length is labeled x, and the width is labeled x minus 4. So even though they have a variable in there, we can still use that formula for area. So the area of this rectangle, is the length, which is x, times, I'm going to use parentheses instead of the x for multiplication since my variable is x. So the length, which is x, times the width, which here is x minus 4. So the area of this particular rectangle is x times x minus 4. But in the problem, they told me that the area is equal to 21 square meters. So that means I could take the a out and replace it with that 21. Because it makes me happy, I'm going to flip what's on each side of the equal sign. So I'm going to move this to the left. X times x minus 4 equals the area, but the area is 21. And I realize that at present might not look like something you know how to solve, but we have a lot of algebra skills that we can use to make it look like something we know how to solve. Even though this left-hand side is factored, we can't set each factor equal to 0 because this right-hand side is not 0. So we can't use the zero product property. We have to make this right-hand side 0. So before I move this 21 over, I'm going to move it to the left. I'm going to go ahead and distribute on the left-hand side. So when I do that, I get x squared, because x times x is x squared, minus 4x, because x times negative 4 is negative 4x. And that's equal to 21. And now I'm going to pull that 21 to the left. So I get x squared minus 4x minus 21 equals 0. So now we've created a problem we know how to solve. We have to look at, do we want to use factoring? Do we want to use quadratic formula? Well, I always try to factor, especially when this leading coefficient is a 1. So I'm going to try to factor. Negative 21 goes in the top, negative 4 goes in the bottom. So I'm looking for numbers that multiply to negative 21, but add to negative 4. And I'm going to be able to use negative 7 and positive 3. So that means I can write x minus 7, x plus 3 equals 0. And now I can use that zero product property that we've been talking about. So x minus 7 could be 0, and x plus 3 could be 0, which means x could be 7, or x could be negative 3. So the question, it's always important to read the question, is it says find the value of x. Well, you can't tell me that it's going to be both of those things. You have to choose. And how do we know what to choose? Well, when we talked about projectile motion, we said we don't have negatives because we can't go backwards in time. Well, a distance can't be negative. So even though negative 3, we understand how long that is, right? If we took absolute value, no one's ever going to tell you the dimension of something is negative 3 meters. It's just not going to happen. So this is not the solution we want. So here, for number 1, we should only have that x is equal to 7. If you put 7 meters, that would be fine. But since it only asked for the value of x, it didn't ask for the dimensions, I would be okay with number 1 not having a unit. Number 2 and number 3 on the notes for today, not the case. But on this particular problem, if you just put x equals 7, I would mark that correct.